Hello, my name is Sachin Prabhu, and I'm joined by my colleague Anoop CS. We both work at IBM in the Ceph team. Together, we will be presenting on the Samba Integration testing, a project which we have been using for the past few years to work on integrating Samba with clustered file systems. We started this project about 4 years ago. At that time, we were working on exporting GlusterFS volumes using Samba. We needed a tool to test our changes to GlusterFS VFS module, as well as ensuring changes to Samba in general do not break the file system integration. Since then, we've had several changes, several improvements, and introduced new clustered file systems in the test matrix. We will describe these changes in more details in the following presentation. So we've split this into the following parts. So we start with introductions, where we quickly go through various components of our test environment. The implementation, a walkthrough of the testing infrastructure itself. Results, some of the bugs which we have, which the testing system identified in the course of our testing over the last year. And finally, takeaways, thoughts on what we've learned during while running these tests. And finally, future, what is our roadmap going ahead? So we start off with Samba. Samba, our favorite open source software for export volumes over SMB. Now, access methods to the backend file system include both VFS plugins as well as export of locally mounted file systems. Next is CTDB. It's used to set up a cluster of Samba servers. It provides the internode communications, allowing us to integrate several Samba servers running on independent machines to run as a single clustered service. Additionally, it also provides us with resource management required to run the service. Cluster, an open source scalable network file system which uses off-the-shelf hardware. Access to the file system is made available through the library libgf API. A fuse driver is also available to mount the GlusterFS volume onto the machine. Apart from Samba, volumes can also be exported over NFS using NFS Ganesha. Unfortunately, GlusterFS is no longer under active development. So we come to Ceph. This is the center of our attention at the moment. Like GlusterFS, an open source scalable clustered file system, which uses off-the-shelf hardware. Access to the file system is available using the library libCephFS. The CephFS file system itself can also be mounted onto the machine using a Ceph kernel module or using the Ceph fuse driver. The volumes can also be exported over NFS using the NFS manager module. As seen in the presentation earlier by John Mulligan, he is working on an SMB manager module for Ceph, which uses Samba underneath and will allow us to manage SMB exports directly from Ceph. GPFS. GPFS is a general parallel file system, which is an IBM product, which similarly provides a clustered file system. This is part of the IBM Spectrum Scale product, and access to GPFS volumes is via GPFS VFS plugin as well as through file system mounts. This, at the moment, is at an early stage of integration on our test infrastructure, and we have just about started running our tests against GPFS to test the integration, the GPFS Samba integration. And finally, the challenges. The main challenges we face are there are multiple machines involved. We are working with a clustered file system, which is hosted over multiple nodes. There are multiple projects involved. We have Samba, CTDB, then the file systems itself, the Ceph, etc. Then finally, multiple ways of accessing the backend file system. We can access the file system through VFS. We can access them through local mounts. Now, all these need to be tested. So the requirements are we need to automate our setup of the cluster. We have to use a test runner to run the various tests. And finally, we need to run these tests periodically or after any changes to any of the components which are part of the cluster. So the project, when it started 4 years ago, it started off as the Samba Integration project, which was hosted under the Gluster project. However, GlusterFS is no longer under active development, but we were looking to use the same infrastructure to test other clustered file systems. Another problem we faced with the repo was that it was made up of distinct parts, which was hosted under different branches. This made maintenance more difficult. So we gave the project a new home, and we split the parts into its own individual repositories. So yeah, Anoop.
Yeah. So Samba build, it's a repository, individual repository under the Samba in Kubernetes GitHub organization. It basically builds Samba RPMs out of the master branches and also from the active release test branches. Currently, we build RPMs from the above mentioned branches for CentOS 8 and 9, and also for active Fedora releases. Currently, it will be Fedora 38 and Fedora 39. The repository link, as you can see in the slide, it's under the Samba in Kubernetes GitHub organization. And we have set up nightly builds so that we have the RPMs built every nightly, which can be consumed from the test runs that we have in the job configurations. And in addition to nightly runs, any changes to the Samba build repository itself, any configuration of the spec file changes, will be tested as part of any pull request raised against the repository. And the RPMs that are being built as part of these jobs are publicly available as artifacts from the URL mentioned in the slide. Coming to the Samba integrated testing environment, this is another individual repository which contains all the Ansible playbooks that are being used to bring up the cluster. Individual nodes that we bring up for the cluster creation are virtual machines. And these virtual machines are created using Vagrant along with the libvirt plugin. Due to the various dependency or the pain in maintaining the dependencies for Vagrant, we have a plan to get rid of Vagrant and just use libvirt so that it becomes more easier. So with the Samba integrated testing environment repository, the playbooks inside that particular repository creates the entire cluster that is required for the testing. And these are some of the updates from the past 1 or 2 years that we have done to this particular environment itself. It has become highly modular. Initially, the playbooks were all mixed up. We didn't have any separation between the cluster setup, Samba, CTDV setup. So that was a problem. Right now, it is highly modularized. In addition, we have options to provide smb.conf options or any file system specific config parameters. Those can be provided as input and it will be taken into effect. The common cluster config is now being created dynamically out of various settings files. These settings file can be located under the personal path in the user's path, or it can be local to the repo, or it can be the settings file that comes within the repository. While creating the cluster configuration dynamically, we merge everything with a highest precedence given to the personal settings. And also we have support for heterogeneous cluster in terms of the host OS. Previously, we had everything on CentOS Stream 8, and now with CentOS Stream 9 support added, it has become the default. there are various or certain cases where we are still stuck with CentOS Stream 8. And in order to execute certain test cases, direct access to the file system was required. Thus, we have now provided an SSHFS access from the for the cluster from the client machines.
So Samba integrated testing, the test cases. This repository is hosted at the URL above. The tests itself are available in the test cases repository. It's not necessary that these tests have to be run only against an environment set up with the SIT environment repository, but by providing a configuration file, users can also run these tests against any file server providing us with SMB access. Now, there are several types of tests which are run. These are run nightly or when we make changes to the repository itself. We hope to change this shortly by introducing GitLab runners to test with clustered file systems when changes are proposed to Samba itself. So updates. The earlier avatar of this repository was a mixture of Bash scripts and Python. We have now exclusively moved to using Python, and we use PyTest as the test runner. The tests themselves are run in a Tox environment, which automatically installs the required dependencies and runs the tests. The Python modules are made available to help make writing of new tests easier. Where possible, platform-independent code is used. This makes it possible to run some of the tests from a Windows machine as a client. Now, containerized tests are also supported. This is meant for use with projects such as LTP and small file tests, which are separate projects which have their own dependencies. We use containers to package them, and the test system can now easily consume them as part of the tests which are run using the test runner. We also have new IO tests which are run against the exported volumes. One of these, for example, is a loading test which opens multiple simultaneous connections to the server and performs IO operations. The aim is to check if the server is able to handle a set number of simultaneous connections performing simultaneous IO. While we are slowly improving the SMB at the same time, we are slowly improving the SMB torture coverage. Any shortcomings identified are reported both to the clustered file system and to the Samba team as required. Some of the examples are described later in the presentation.
Yeah. So CentOS CI, this is the platform or the infrastructure that we use for the above mentioned projects. So everything explained till now is being run on an infrastructure provided by CentOS project for open source community projects. We are glad to have a dedicated namespace for Samba. We have a pool of bare metal machines. That's from where we reserve machines. It can be bare metal machines or virtual machines itself. That's a pool common to every other project incorporated within this infrastructure. The pipeline itself is set up using the well-known automation server Jenkins. It is already deployed on top of an OpenShift container platform. All the required OpenShift configurations, the Jenkins job configurations, and whatnot, everything resides in another repository, for which the URL is given in the slide itself. It is called Samba CentOS CI, which also comes under the Samba in Kubernetes GitHub organization. You will find everything that's needed to have the job configurations set up. And here is how the workflow. So as mentioned earlier, we have nightly runs for building the RPMs. That was already mentioned. In addition, we have the clustered test run, the full test suite that we have set up currently. It will be also run as nightly runs, and the results will be reported. We have notifications set via email for failures, along with the logs and the failure, whatever tests that are failed. So we get to know what's the status every night. And the GitHub PRs to the SIT environment or SIT test cases repositories are also configured so that any PR or any pull request to SIT environment test will trigger a sanity test. Any pull request to SIT test cases repository will trigger a full test run. And the current test metrics includes various to file systems with various access methods, CephFS, CephFS with VFS module, 2-3 variants for the GPFS, and we have a baseline setup with XFS file system too. Yeah, here we have two screenshots from the infrastructure in action. Towards the left, we can see a specific Jenkins job page for CephFS VFS integration, which is an integration using the VFS Ceph module within Samba. We can also see a quick view option to view the test results in the very same page. And adjacent to that, we have the logs and also the configuration from all the nodes involved in that particular test run. And towards the right is where we have the screenshot from the entire test results accessible. It is accessible when we click on the view button from the previous page. So I'm not sure whether we can see all the details from that page, but it basically lists everything, whatever test was run, what was the result, whether it failed, did we skip, yeah, those kind of results are included in that particular view page. Yeah, and results. So we'd like to explain few of the issues that we have encountered while running these test cases every nightly. So this is one of the issues from the SMB torture test case called test suite called smb2.mkdir this started failing as soon as we enabled the particular test suite, and it turned out to be because of the lack of SMB VFS fstat implementation, fstat implementation. So basically, it ended up executing from the VFS default module instead of the VFS Ceph module, and obviously it will fail when we check for the path, and we didn't have the path there, so it failed with e not dir. So we had got an empty status, not a directory. So immediately we fixed it by having an implementation within VFS Ceph module for SMB VFS fstated. The merge request link is provided in the same slide. And the next one was an interesting one. We started including a particular test suite called smb2.timestamps. This was a fairly recent one. And we noticed failures. Some of the subtests failed to retrieve the expected create time. In Samba, in addition to statex info, the beat time was also saved as part of dose attribute value. What happened here is that VFSF failed to update when a timestamp was changed. And also, we ended up having two sources for timestamp, basically a value from stored as part of those attributes, and also the one from the statex info. So we decided to always rely on statex info, and that's how we fixed it. But even after fixing it, a few other tests from the same test suite failed. This was because the values that were being set for the timestamps were beyond the unsigned int32 max values. And it was turned out to be a limitation from CephFS side, where the time structure used just were limited to unsigned in 32. So any other value greater than that particular limit is expected to fail. So right now our test suite run with a flapping list. We do have a flapping list for every file system. So we have put those subtests into a flapping list right now. At the same time, we are working with a CephFS tracker that is already filed to get it fixed from the CephFS side. Yeah, this was a regression, and this was a prominent one. It was a regression when we used a VFS accelerator module. We had a change sometime back within Samba to prefer DAC override capability instead of become root. We do have a fallback mechanism, but the preference was given to DAC override. What happened here is that we started noticing NT status access denied in our SMB torture test. And in our environment, we had SE Linux already enabled. Initially, we thought it was just due to SE Linux being enabled in the system. But it was not just SE Linux. It did fail even otherwise because DAC override was not the only capability required to set particular security accessors from the security namespace. And the upstream CI with GitLab, it runs within container. So there the fallback already happens, and it happens always. So we failed to notice that change failure. But unfortunately, we couldn't come up with a clean approach to handle multiple capabilities, setting of multiple capabilities. And we partially reverted the change for VFS accelerator. And we ended up reverting every change in entire Samba before 4.20 release because we encountered similar issues on other parts and not necessarily with VFS accelerator. So we ended up reverting every changes which preferred DAC override over become root. And finally, this was a smaller one. SMB2.maximum allowed test suite had some failures with NT status object name collision. The subtests were failing due to leftover of the files that were created from the previous subtest. Basically, the unlinking call return status was not considered, and we ended up clashing with the subsequent test. So the root cause was there were not necessary permissions set on the file so that it can get removed. We fixed it with an additional security descriptor or ACL set on the file before attempting to unlink it.
So some of the lessons learned. The project helps improve developer workflow by providing a clustered environment quickly. This environment can then be used for testing your changes on the clustered file systems. Once using the test, we've been able to identify regressions caused due to changes to upstream Samba. Some of these have been discussed earlier, and this has saved a significant QE time. But where we are still lacking is when it comes to testing clustered file systems against merge requests for commits to upstream Samba. For example, some of the changes which were added to upstream Samba ended up breaking some of the clustered file system integrations. But because of lack of testing, these changes were committed and resolved later as these problems were identified. These regressions could have been avoided by testing before these patches were committed. In the future, we would like to work on a GitLab integration so that the merge requests can be tested against clustered file systems as well. We would like to increase the number of tests as we identify areas which require additional testing. We also need to look at testing stable branches. For example, the Samba packages provided by Red Hat Enterprise Linux. This at the moment are these packages are not tested against clustered file systems. This is something we would like to do as well. Thank you. So, any questions?
What kind of bugs did you see with clustered file systems and Samba? What was the nature of the problems?
So some of the issues we have listed in the presentation itself. There were 4 of them listed. Some of them, for example, the DAC override issue, which was a way of becoming root. So that was replaced by the DAC override capability. Unfortunately, that caused regressions in our environment. That itself was not directly related to clustered file systems, but it caused problems in our environment because we were running SE Linux, and SE Linux prevented the user from doing that. Some of the other issues, for example, the OPA changes which were added a few years ago, that ended up breaking the integration, I think, with both GlusterFS and maybe, I don't know about Ceph yet, because that time we were testing GlusterFS. I remember those the integration, the GlusterFS integration, they're breaking, and we had to then subsequently fix the GlusterFS integration. That this is after these OPA changes went in. So if we were able to test these clustered file systems during the merge request phase itself, we would be able to avoid this particular problem. So we wouldn't have regressions essentially.
The whole Ceph module was broken for a little while anyway, so you wouldn't have been able to get that far.
How hard would it be to integrate it into the submissions testing, automation?
So Anoop has been working on that. So Anoop, maybe you can step in here.
Yes. So the integration itself is not a problem because the Jenkins to GitLab integration should be easy to set up. We currently do not have a method to basically test the source installation of Samba against the clustered file system. We do have a long route to have the RPMs built out of master and then consume it for our testing infrastructure. So that is possible. And this is doable. And this is something we have in pipeline for maybe this is something it will be discussed soon. And hopefully we'll see our testing infrastructure results as part of the GitLab merge request for Samba. That's what we will be doing.
So Sachin, my worry about that is that, say, for instance, the OPATH changes, they were security fixes. And so, as I recall, libceph simply didn't have the calls that were needed.
Yeah.
So that's basically a, yes, we broke Ceph, but the alternative was to be insecure because Ceph didn't provide the fixes needed. So it would have been nice to know that we've broken it, but I don't know that we could have stopped the merge of those things.
Yeah, I just use that as an example. There could be other similar examples which could come up in the future, which could end up breaking.
I mean, can't we make that a known fail then, with a specific reference to the Ceph environment?
Yeah, that's probably the way to go. I mean, it's nice to know.
Yes,
but I'm just saying,
known fail is a big kitchen sink of stuff that we need to fix.
Yeah. Will the new module provide more accurate sort of POSIX semantics on top of Ceph?
I don't know. Shahar maybe can add to that. Shahar is working on the new CephFS module, so. Yeah, he says yes on chat.
Hooray! Yeah, I mean, I'm excited about that module, but yeah, I would love to see it in our test environment. That would be great.
I think it's, however, one warning, if I may chime in quickly here, Jeremy. So this, I think you're referring to the new low-level API module. So replacement for the CephFS VFS module in Samba that will use the low-level APIs from Ceph. And so Ceph is not going to be providing directly those other costs that we need, but implementing them here by using more low-level things to implement the functionalities that we need. I think this is what is going to do. Shahar can chime in and correct me if I'm wrong here. But the important part is that we will be able to satisfy the needs of our VFS module, the newer ones.
Yeah, I mean, once we have the low-level module using the low-level API, we should be able to basically massage it to get the POSIX semantics that we need. And if it doesn't, then we can at least flag them as bugs, and as Volker points out, we can just add known fails until the low-level API provides what we need.
Right. I mean, so the important part is to satisfy these needs for the add variants of the calls, etc. I think that's probably what you're referring to. And that's going to be provided by the lower level. Shahar has
I mean, the app variants are basically table stakes for a secure Unix file system.
Yeah, right.
If you don't have them, then thank you for playing. Go away.
Just to mention OPath, I mean, we are moving towards using OPath more and more, and so if you don't have that on your table yet, just put it on there.
Just to mention that the current VFS Ceph module already makes use of the at variants. That's what I can say. We have made enough changes there, and yeah, that's the current status. We do have the at variants and all the related changes already merged.
Which is
good. That's great. Sorry, go ahead, Volker.
Yeah, what we like and what we use more and more and what we will use more and more in the future is this O_path thing. And I mean, the main thing here is that it gives you a reference, essentially a read-only reference to the inode without checking for permissions that you can then turn into a real file descriptor. And this gives us really a secure handle also, for example, to symlinks that we can then later read in a safe manner.
So just looking at the code, it seems the VFS Ceph module already does use and support O_path.
Oh, that's great.
Yes, right? That's okay. Maybe I did not mention it specifically, but yeah, that's the current situation with the VFS Ceph module.
Yeah. So another bit that might be very helpful performance-wise, I haven't checked just that as well. If you already support that, maybe I don't remember, and that is the OpenAdd to Syscall, and specifically its resolve no symlinks flag. That's a very important one.
We don't have that yet.
Put it on your list. Very helpful for performance because it avoids walking path components in a potentially very expensive way.
Anisha will love that as well, I guess.
Sure.
So one of the questions we have on chat is the current recommendation for non-containerized environments, whether we should go with the kernel mount or whether we should use VFS Ceph. Now, we would like to go with VFS Ceph, but there are some limitations which we know about. Essentially, it relies on how many connections do you have, simultaneous connections do you have at the same time. There is a caching layer within the libCephFS. So when using VFS CephFS, we could end up running out of resources on the server machine. When you use a kernel mount, what happens is the kernel acts as a proxy, and all the caching is handled by the kernel itself. So that is we've noticed is far better for resource handling. But we hope to fix this going ahead.
And
Yeah.
I'm not even sure if this is related at all to the question whether it's a containerized or non-containerized environment. I think it's a general recommendation.
Yeah, it's a general recommendation. Yeah.
Right.
Just wanted to point out that there's actually work undergoing at the moment in order to construct something like a proxy within libCephFS itself. So Xavi, who's also here, he's currently working on the infrastructure of that, and yeah, it's with some interesting results. But the work of this really just has started. So there will be more updates in the future. And also one other thing I quickly wanted to point out, the testing that is done in this testing environment for the clustered file systems consists of, among other things, a lot of SMB torture tests, but it's not really running the entire make test like you would expect from Samba testing. So it's really only using a limited list of SMB2 relevant tests. So also in this sake of kind of limiting the amount of resources and time that really is required to fulfill all this tests to be completed, in particular on clustered file systems where you have many additional latency and other timing relevant aspects to be taken care of.
Well, what we found is Samba is a great tool for finding corner cases. So we've been able to identify bugs which we on clustered file systems which we wouldn't catch otherwise with the other methods of testing.
What you're saying is Samba really hates file systems.
No, it gives it a good workout.
Yes,
Or
it
the
gives
other
them a
way
good
around.
kicking.
File systems hate Samba because Samba is good at finding bugs in them.
This is true.
Yeah.
Okay, I guess if that's it, then thank you very much. And hopefully we see some more progress on the list.